Hello friends, this is Durga from IT University. As part of today's session, we'll be talking about uh, innovation using data science. This is a workshop and it is conducted by Byte IQ. We have some sessions earlier where we have introduced about this program. Now, before starting enrolling for the program, we just want to give the workshop about how the training will look like, and also we want to ensure that you pick some skills as part of this workshop. That's why we name it as a workshop. This is a free workshop. You don't need to pay anything for this. Yeah, if you are interested to enroll for the program after this workshop, I will give a WhatsApp link and you can actually join that WhatsApp and we will follow up on that. This is for those who are joining in the YouTube. For those who are already part of the Zoom, you don't need to do anything. You can just show your interest as part of the group, WhatsApp group, which you are already part of. If you haven't got the WhatsApp group invite, please ping me on Zoom. I will share the link and you can take it further. That being said, let me copy this WhatsApp link in the Zoom chat. So those who, sorry, not in the Zoom chat, but in the YouTube chat, those who are joining from YouTube while this program is, while this workshop is going, if you want to be part of the WhatsApp group and if you want to get the follow-up information with respect to enrolling for the 120-hour program, please join the WhatsApp group and we will take it further. You can ping us anytime and either me or Arya will address your questions, and then we will see whether you can be part of the program or not. That being said, let me hand it over to ByteIQ team so that they can actually go through the workshop. Arya, you can take over and you can drive the workshop.
Thank you, Durga. So good morning to people who have joined from US and good evening to those who have joined from India. So in today's session, we are going to cover three major aspects. Can we move to the next slide, Mike? Okay, so we will introduce data innovation as a concept to you guys. I think in the first one, the first introductory call, I spoke a lot about data innovation. Today, I'm going to just reiterate the significance of data innovation in the space of data science. And then we will take you guys through two examples where data innovation got translated into data science solutions or products. And lastly, we will show you the implementation of a machine learning model in the area of campaign management in the banking domain. So that's that. In that section, we'll take you guys through the Python code where we will show how data is ingested into the model and how the model is trained, how model is tested, and how model is evaluated based on the performance and then taken forward. Okay, so moving on. Can we move to the next slide? Yeah. So I spoke about data innovation, I think, a lot in the previous introductory call. Still, I would like to spend some time because the program which we are offering is primarily based on data innovation, even though it is a data science program. But our experience of corporate world has told us or has shown us that the value of data innovation is significant in any data science program. And almost all the programs I have come across in the area of data science, I have never seen any program being driven by data innovation. So every organization bring in highly talented data scientists and they expect the magic to happen from the data, and that is
Hey
something
Arya,
which is, yeah.
a quick interruption. Sorry to interrupt you.
Okay.
So those who are on YouTube, if you want to join the Zoom session at any point in time to get the information without any latency, and also if you want to raise any questions while the session is going on, feel free to join the Zoom session also. So this is for the folks who are part of the YouTube but not in the Zoom. But once you get into the Zoom, make sure you don't try to access both via YouTube as well as Zoom. It will cause confusion. So if you are interested, you can switch over to Zoom, and I will add you to panelists also. In case if you want to ask any questions midway, you can actually unmute yourself and ask the questions, even though you are not part of the Zoom invitation. Now I'm sharing it with you. So feel free to join the Zoom session and ask the questions in the Zoom. Once again, I'm reiterating, while the program is going on, if you are interested to enroll for this program, I have provided YouTube chat also, sorry, not YouTube chat, WhatsApp chat, WhatsApp group link. You can just join WhatsApp and you can follow up with us. Yeah, go ahead, Arya. Sorry to interrupt you.
No issue. Are you guys observing any disturbance from my side, or it's all okay? I should have checked at the beginning.
It's all fine. There is
It's
some
good.
wind sound, but it's not that disturbing.
Okay,
It's fine. Yeah.
okay, okay. So yeah, I was talking about data innovation. That my experience of various data science programs, and when I interact with various data leaders across companies, across industries, what I have noticed is nobody talks about data innovation, but everyone talks about the magic which they are unable to see on the data. They feel that they have hired best data scientists from the market, they have invested a lot of money in building the big data infrastructure, but where is the magic? What data scientists are doing are basically taking the business problem from the business and working on it. Okay, so that is minimum which they expect data science team to do, but the real value they are unable to see, because data is there to give a business competitive edge. But at the end of the day, business is just doing a catch-up game with their competitors. If competitor has done some analytics using their data science team, then the company will come and ask the data science team, can you do something for me like this? Okay, but there is huge value. There is what companies are doing is like they are looking at the tip of the iceberg and harnessing 5 to 10% of what value is there in the data. There is a lot of value which is there underneath, which business normally go into or not data scientists go into, and that's where data innovation comes into picture. Obviously it requires different kind of mindset, different tools, techniques to do data innovation, but my belief has been, if you have a strong data innovation framework encapsulating your data science program, then the data science program is going to create wonders for the organization. Okay, so that's why in this program which we have been offering, we focus a lot of data innovation, so that the real values out of the data comes in the form of solutions and product ideas, which data science team can implement using the data science tools and techniques which they learn. So data science will obviously be taught in the program. That's the focus area, but we consider data science as a tool which will help data innovation to go to the next level. So with that, we will move. Now we have spoken a lot about data innovation. You guys would be wondering, what exactly is data innovation? Is it a glorified version of data analytics or data science, or is it something different, completely new? So my point is, it's completely new, which you will get to know. We have separate sessions within our data science program, which will focus primarily on data innovation, and we have our own framework around data innovation, which we have applied in many companies, and it has yielded success stories in every place wherever we have applied, irrespective of the domain. We have applied in the pharma domain, we have applied in the airport, on the airport data, we have applied on airlines data, logistics data, microfinance, insurance, everywhere we have applied and we have seen the success. So with that, can we move to the next slide? So we are going to talk about one example of data innovation in action, which we recently did with one of the companies we were engaged with. It's in the area of suppliers. Can we move to the next slide? So for people who don't know who suppliers are, basically they play a very critical role in any manufacturing company. Okay, so the objective of a manufacturing company is to take raw materials from suppliers, process it, create the finished products, and sell the finished products to customers. Okay, and suppliers play a significant role, because 30 to 50% of the revenue of a company is actually is the money which is spent on suppliers. Okay, it's what I think it's the biggest cost of any manufacturing company, followed by salaries they pay to their employees. Okay, so during the exercise which we did with one of the manufacturing company, where they wanted to check how data innovation is working on their suppliers data, we started with an analytics landscape study, where we tried to understand what all analytics is already happening on their data. So we looked at the data sets which are primary in nature for that business. We looked at what kind of reports and analytics are getting generated out of that data. And then we realized that it's mostly some dashboards and the reports which are getting generated. They have a data science or data analytics team, but not much value is getting out of the data or out of that team. And that is what the problem which procurement head of that company was facing. And they wanted us to do some innovation, so that AI, ML, or other data science techniques can be leveraged to generate higher values out of data. Okay, can we move to the next slide? Okay, so this is basically what you see on the left side is the data innovation engine. So this is basically our framework, which we have coined as entity science. There are so many frameworks and models under entity science umbrella. We have a framework to uncover what are the various entities in a particular area or in a particular data set. So when we look at data set, or if you guys start to start to take a step back and look at any data set, you will always find that every data set is structured around an entity. An entity can be a supplier. In this case, entity was supplier. It could be an employee, or it could be customer. It could be sales manager. It could be relationship manager. It could be an application. And some, if you're trying to build some application 360, then application becomes your entity. It could be invoice in some case. So entity is that object which is of analytics significance for the business, and the data which we are doing research on is structured around that entity. So if I take any data set, I will see bunch of entities. It's not only structured around one entity. It could be structured around a couple of entities, but we typically see one entity as the primary entity. So most of the data elements in that data set, what you are researching on, will be structured around one entity, and that's the primary. Then there will be some secondary entities who don't have significant presence in the data set, but yeah, some presence is still there. That's why they are called secondary entities as per our framework. And third is the derived entity. When you look at the data set, you feel that this entity has a minuscule touch point, just one, let's say one data element is there, or one variable is there with some value. But the point is, if you merge that column with some external data. When I say external, it could be a data outside the silo in a different department. Then you start to see this particular entity, which is a derived entity, starts to gain more prominence. It becomes a prominent entity to be used in the analytics engine. So we have a framework to discover such entities. We have another framework which we call it as entity canvas, which will help us to put various entities on the canvas and then do some model work and identify the entities which are of significance from analytics perspective. Because when we are trying to discover entities, we may come up with 8 to 10 entities, but all entities may not be of significance at this point of time for the business. So using some model, we need to derive which are the entities which are of significance for the business at this point of time. Once we discovered those entities of significance, then we have another framework around landscape of the entity, which is basically trying to understand all the aspects of the entity. Okay, and that landscape has to be presented to the business to get their confidence in the data innovation exercise. Okay, that's another approach we have within the entity science. Next is entity life cycle. Once we have identified an entity, we have understood the landscape, and we know that this is of significance for the business. How do we create a life cycle of an entity? Basically, this is the phases through which an entity will move within the organization. We'll talk about it on the right hand side. And the life cycle is very critical, because in each phase of the life cycle, data is either generated and consumed. Okay, then comes the entity 360. Again, one more framework from our side, which brings three layers of information together to build an entity 360. The layer one is all about basic metrics associated with entities, metrics which are less likely to change. Layer two is all about summarized metrics like monthly numbers, average transaction size. All those are like secondary metrics. Third layer is analyzed metrics. This is where we apply some model to generate metrics for the entity. But at the end, we have an entity 360. So in this particular case, it could be supplier 360. Okay, so we have entity 360 as a framework. Then there is another framework to establish relationship between various entities. We have uncovered one entity, we have uncovered another entity. Are there any relationships between all these entities? So we have again another framework to discover such relationships. Then the value lens. Once we have created the entity 360, we have understood all the relationship. How do I look at my entities to generate ideas? So we have three values like cost or revenue as one of the lens. Then we have risk as one of the lens, and quality as another lens. Through these three lens, if we look at entity 360 and the relationship, we will start to see the newer things that is there in the data, the higher values that is there in the data, which business has so far not explored. So the value lens actually will lead to new values coming out of the data. And last is value index, again another framework which we use. Once the value has been seen, then you need to quantify the value so that business is able to understand. So value index helps us to um, quantify the value which we have seen through value lens on entity 360. So that's the entity science framework which we have come out with, and we are using it in many places. We have used, and everywhere we have seen success, and this is something we are using in our program also. So we as part of our program, we are also teaching our students what is entity science, how they can take one data set through the entire entity life cycle and come out with interesting ideas and whatnot. Now, coming back to the supplier scenario, we applied the same entity science framework on the supplier. And what you see on the right hand side is the life cycle of a supplier. Like the phase one is about the onboarding the supplier. When we onboard the supplier, what all things we do with respect to that supplier? We identify the product and or the services which supplier is going to provide. We set some price. Okay, at this price, supplier is going to provide me this good. What is the discount, minimum discount I can expect from this supplier in each and every transaction? What is the minimum number of days I'm going to get from this supplier before I make the payment once the invoice is raised? And there will be a relationship manager who will be assigned to this particular supplier. All these things happen in the onboard phase, and these are all data points with respect to that supplier during the onboard phase. And once the supplier has been onboarded, then let's say because of some need, the business wants to raise a purchase order. So purchase order will go to various suppliers, which will have the number of units of goods, the goods, raw materials the manufacturer wants to source from various supplier, at what price they want to source. Again, purchase order generates a lot of data. Then one of the suppliers would be selected, and the supplier's good will come to the manufacturing unit. So then that phase is called goods procurement. Again, a lot of data gets generated. How many units of raw materials was provided by the supplier, at what price? Did they meet the initial requirement, or they supplied less than what was asked for? What is the wastage in the process? All those things get analyzed, or data gets captured in the procurement phase. And once the goods have been procured, then the next is invoice. The supplier will raise an invoice, the amount will be mentioned, the currency will be mentioned, date on which it got generated, by what date they need to get by what date the manufacturing company needs to pay to the supplier. Again, bunch of data points getting generated. Then the payment, then the risk review. I think over a period of time, then the manufacturing company has to keep reviewing the risk profile of the supplier, so that the disruption is not there. If a supplier is becoming risky because of certain factors which are impacting the way the supplier is doing business, then supplier risk level will go up. Maybe company will decide to move away from that supplier to some another supplier. Again, that generates a lot of data. So each phase is actually generating a lot of data. So we did this supplier and supplier lifecycle management, and in each phase we generated a lot of data and created entity 360. And then when we used our value lens, we came out with bunch of ideas. Like I have put some as an example there, like supplier segmentation. How do we segment all the suppliers in the portfolio? Are there suppliers who are emerging in my portfolio? Are there suppliers who are dying? Are there suppliers who are already dead? All those things. Then the concentration risk. Am I doing or am I giving for a particular raw material which is of high significance to my manufacturing process? Have I given that or am I sourcing that raw material from one supplier only? Or 90% of the 90% of the amount quantity of the this particular raw material I'm sourcing from one supplier, while the rest all suppliers are giving me 10% of the raw material. So am I building risk in the process? That's stress test, invoice risk score, and RDI. So RDI is what I thought I will share with you guys in this session. So RDI will talk about it in the next slide. But yeah, this is what we came out with, and this was developed with a data science stack consisting of Python, MySQL, Tableau, and from machine learning algorithm perspective, we use linear regression and k-means. So k-means is unsupervised machine learning algorithm, which helps us to design or create index with respect to all the suppliers. Any question before I move to the next slide? Fine. Now, if you guys are wondering what is RDI, RDI is relationship depth index. Again, term which was coined by us, and this was something we proposed to the business when we asked business, do you have any index through which you can calculate what is the level of engagement you have with a particular supplier? You have thousands of suppliers in your portfolio. Do you know who are the suppliers with whom you are highly engaged? And the obvious response which we got was, okay, the suppliers with whom we do a lot of transactions are the supplier with whom my amount of transactions is highest. Top 5, top 10 suppliers, those are the guys with whom I have high RDI. That's what the response we got. We told that is not high RDI. And even if you are doing a lot of transactions with these guys, but your relationship has been steady, these guys have been doing that many transactions or that amount of transaction for last 6 months or 1 year. There is it's not like you have deepened your relationship or engagement with with these suppliers. But what RDI can do is RDI can look at other factors. RDI can look at factors like, what you see on the right hand side is obviously the transaction amount, goods, transaction amount, the volume of transaction, they will have a significance, but higher significance will be given to transaction trend. Okay, when you started the engagement with that supplier, you were doing $1,000 of transaction, but in 6 months you are seeing $10,000 worth of transactions happening. That's a serious deepening. When you started the engagement, you were sourcing just one raw material, but by June month or in 6 months you are sourcing, let's say, 10 different raw materials. That's deepening. The concentration, you when you started sourcing that raw material, this supplier was giving, the supplier share was like 10% of the raw material. Now in 6 months this share has gone to 90%. That's like serious deepening. Okay, and every week you are doing the transaction, and all these factors we brought to the fore and told that if you have to look at the real engagement level with a particular supplier, you should be looking at all these factors together to arrive at those set of suppliers with whom you have high engagement. Also, humanly it is not possible. If I put 9, 10, it can grow to 20, also 20 different metrics which can be taken together to understand the engagement level. For a human being, it is not possible to go through all 20 and come to a conclusion, okay, these are the guys with whom I have a deep relationship and these are the guys with whom I don't have that much strong relationship. So that's where we told that you don't have to worry about that. We will bring all this together. We will leverage machine learning model to create one score, basically one index, which will tell what is the level of engagement. So on a band of 1 to 10, we'll create one score for every supplier. So the supplier who have got high score, they the engagement level with those suppliers are seriously high. Okay, so you need to look at those suppliers. Okay, and that concept is basically relationship depth index. And the question was, okay, I create or you create for me this RDI, but how does it help? First of all, you know with whom you are. That's informational in nature, which is highly important for senior execs and leads and others to know. Second thing which made a lot of difference in this innovation exercise or this concept of RDI was, we told that let's assume a supplier with whom you started your relationship in the month of Jan with a visibility that you will be doing $1,000 of transaction for next couple of months, but in 6 months it has gone to 10,000, which you never imagined at the beginning of the engagement relationship. Okay, so when you started relationship, maybe you agreed to 1% discount. I'm just throwing a random number. 1% discount was okay for you because you did not have much visibility. But in 6 months, your number of products have gone up from 1 to 10, and amount has gone from 1,000 to 10,000. So it's a serious engagement you have got into with this particular supplier, and 90% of your business you are giving to this supplier with respect to one particular raw material. Don't you think you deserve more discount? Instead of 1%, don't you think it should be 1.5 or 2%? And this is a significant amount. 1.1 from 1 to 1.5, it's a huge, because as I told, 50% of a company's cost could go to suppliers. So even 1% difference would be a huge difference to the bottom line of the company. Okay, so this is how it is going to help you to go and have a discussion with the supplier, show them this story, and no supplier can deny this, and no supplier can say that I don't want to give higher discount. I cannot give higher discount. If you tell this story, in today's world, you are unable to tell this story. Okay, and all this signals or all these changes which have happened, it's is unknown to you, unknown. Maybe they know, but why will they bring up? But it's not known to you guys. So if you go to the supplier with all these data points and the story, then no supplier can say that I cannot give you more discount. Okay, that is one thing. The other thing is RDI will help you to uncover those suppliers with whom you are decreasing your relationship, which could be consciously you are doing, or unknowingly you are doing. But if you are consciously doing or unknowingly doing, whatever may be the scenario, if your level of relationship is going down, then it's high time to do a cleanup act. Because every company we have, I spoke to a bunch of companies on the procurement, and everywhere one of the problems I saw was the talent spend. Everyone was talking about talent spend. So talent spend actually are with respect to those vendors or suppliers who are providing very less goods or services once in a while, and very less number of transactions are happening, very less amount is being paid, but still they are in the portfolio. Still they are part of your list of suppliers. You are maintaining those suppliers, you are doing risk. When you have a supplier, you need to do risk review. Okay, so much additional cost is there in managing one supplier in your portfolio, even though you are not giving any business. So every procurement head is worried about that talent suppliers. So our theory was, if you have a strong RDI framework in place, you can uncover those suppliers who have got low RDI, and then you can follow the cleanup act and to get rid of your talent suppliers. At least some portion of your talent suppliers can be removed from your portfolio, so that again your cost is coming down further. So with this, we will go to the demo of the RDI which we did in this engagement. Any question before I go there? Fine.
Feel
So
free to
this,
unmute. Feel free to unmute yourself and ask the question. If anyone have any questions, or you can also ping in the chat. I will take the questions to Arya. Let's give 10-15 seconds time, and then
okay.
we will proceed further. Those who have joined through YouTube, if you have any questions, feel free to join the Zoom session. The link is there as part of the chat, and you can ask the question there. Also, feel free to join the WhatsApp group in case if you are interested to enroll for this program at any point. If you feel this is interesting and it makes sense for you to enroll, just feel free to join the WhatsApp group and follow up with us. Yeah, we can proceed, Daria.
Okay. I hope now you guys would have understood the difference between just a data science technique and data innovation leading to a data science solution. Okay. In case of data science, normal data science programs, a business will come, and if business will say that I want to calculate RDI to understand my suppliers, then the data science team will have discussion. What do you mean by RDI? Can you give us some definitions of RDI? Can you break it down to subcomponents? And then once they understand what business is referring to RDI as, they will start building the model. Okay, but in case of data, and most likely business will never come to data scientist with RDI as a concept, because business is worried about their business. They are thinking about, how do I bring down the number of suppliers I have in the portfolio? How do I save cost? That's their main objective. Okay, they are not thinking outside the box to come out with a new concept, new approach, new solution. So that's where data scientists can play the role. Data scientists are part of that portfolio. They understand the data of the suppliers group. Okay, they are dealing with data day in day out. Only thing is, if they start to apply innovation on the data, they take that standard, the approach or the framework which we are talking about, they will come out with RDI as a concept. They will go to business and tell that we think RDI is something you guys need to focus on. Then business will ask, what is RDI? Tell me, can you explain me? And once the data scientist starts to explain, business will see, oh, wow, this is something I never thought of. This is real invention you are talking about. Can you guys develop it? Then it becomes a data science problem. Then the model development will not take much time. If you guys are trained on how to do the model development, you can do it. The 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 significant thing here is, or the most important thing here is, that ideation phase where you are coming out with the concept of RDI. So that's the
Arya,
reason why I have always been focusing on innovation. Yeah, yeah, Durga.
Arya, there is a question from Samba Kumar. He's
Okay.
asking where can we say RDA as KPI?
RDI, you once it becomes a metric you want to track, it becomes your KPI. Okay, but the this KPI is getting generated out of a machine learning model. Okay, it's not a rule-based calculation. You can put a formula and the KPI will come out. Okay, and RDI is not going to be stagnant. Today in today's if this month I have RDI score for a particular supplier as 10, next month it could be 6. Somebody might move from 6 to 8. You won't believe when we started showing them the RDI. Now they are asking, can you build a model to track those suppliers with whom whose RDI score is changing significantly? So like they want to see suppliers whose RDI score has gone up from 6 to 8 in next in 3 to 4 months, or those guys whose RDI score is falling from, let's say, 8 to 4 or 8 to 3 in last 3 to 4 months. Okay, so this is what we actually came out with. We did a prototype and took to them. So what we see as the first is, like I was talking about, the landscape, because landscape is very critical. When we have identified an entity here, entity is supplier, we need to talk about some of the features of that entity. Until and unless we talk about the entity landscape, the other side will not believe in what we are proposing from innovation perspective. And when we go and tell them that in your data we see 684 suppliers, total amount of spending is 318.3 million rupees. Last month you dealt with the 65 unique suppliers, and 137 there are some duplicate names. That's why it's 137 here and 65 in the other field. So once we started sharing this data, they started believing, yeah, okay, I think you are there, you understand our data. And then when we showed the geospatial distribution of from geospatial distribution, the places from where they are sourcing raw material, even some of the places they could not believe that they were sourcing raw material, like wells. Then most of the people, at least the people who came to see the landscape, they did not know that wells is a location from where they are sourcing raw material. And then when we showed it on the geospatial map, they started going little granular, and then they called some people to understand, are we really getting data are we really getting this raw material from wells? So a lot of eye-opening things actually came out during landscape study itself. Okay, so this is overall landscape study. Can we go to, because of the focus for this session is RDI, but we thought since we are coming here, we can show you guys. Okay, then we also created, yes, Mike, can you click one? So we created another feature where we created a time series forecast model to tell how much transaction, or what's the how much transaction they can expect with a particular supplier. In today's world, they don't have any predictive model to tell how many, or the forecast model to tell how many transactions or what's the worth of transaction they're going to see across their major suppliers. So we built some time series forecast model to tell, and this has got high value because in today's world, what they do is that they, let's say they are maintaining 100 rupees to take care of supplier X, okay, without a forecast model. Okay, but if we tell that we have a forecast model which is highly accurate, or we are able to build that model, then and the model says that you don't have to maintain 100 rupees, you just need to maintain 80 rupees with respect to this supplier. So there is a change of 20 rupees. So instead of 100 rupees which they were maintaining in their account to take care of the supplier, now they have started maintaining 80 rupees. And this 20 rupees, the additional amount which they don't need to maintain in the current account of the bank, a current account, they can move to investment account, and that 20 rupees will start making money for them. In the world of procurement, it's all about saving cost, and this is like an opportunity to make revenue. So now if the procurement head goes back to the CEO, CFO and says that, see, I have started earning money for our organization. My job is to reduce cost that I am doing. Now I have started making money. How I'm making money? I'm using a forecast or predictive model to tell how much money I need to maintain in my current account. And with the forecast model, I have reduced the amount of money I need to maintain in my account. And rest of the money which I used to get, I'm putting it in investment account. Okay, can we move to the next one? Okay, this is the example of RDI. So you can see the entire portfolio has been distributed on a RDI score band, and we see this is actually a small portfolio we were doing as a prototype. So we just see 600 odd suppliers, and and can you click 9? And a lot of suppliers are actually dead, that's why you don't see everyone here. So this supplier is got the highest score out of all the suppliers. This supplier got the highest score. If you remember the slide which I showed, where we showed how the RDI engine was built. So this is what basically I have put in the slide. So when I look at this supplier who has got the highest score, I see amount wise it's significant, frequency wise also it is high. Okay, and product count. So 6 is in last 6 months, how many in how many months transactions have happened. So in all the months, in last 6 months, every month transactions have happened. Okay, the product count is 49. So basically various unique products that are sourced from this supplier is 49. Okay, and then you see the supplier amount, see the trend, how the amount has been moving up over a period of time. And similarly with respect to supplied product, from 15 in the month of October, it has gone to 24. So consistently relationship is growing with this particular supplier. So that is the reason why this supplier got a higher RDI score. And now business can go back and have a discussion with this supplier and see whether they can bargain for a better or more discount. In today's world, they are getting 5% discount from this supplier. Can they go with this data and ask for 7% discount? 7 is significant. You can look at the amount. It's significant for the company of this size. Any question? Fine. So that's what we wanted to talk with respect to supplier RDI. Okay, so again, the focus has been on innovation and okay. Okay, can you go back to the previous slides, Mahesh? Yeah, I think no, the next one. Yeah, go back. No, go back. I said just wanted to. No. Next, next, next. Yeah. So the RDI engine which you see here. So and it's not like you can give equal weightage to all the factors based on the business need. We can change the weightage. Like in the RDI score which you saw there, highest weightage was given to transaction trend, unique goods trend. Those are the two factors or two metrics which got higher weightage. Okay. So we got some question, I think. Okay, so the previous one, fine. Okay, so the next one is again from innovation perspective, LinkedIn Journey Analytics. This is an example where we took a data set which normally people will see not much value in. Honestly, this is something which was thrown as a challenge by Durga at us because I was talking so much about data innovation that we can apply innovation on any sort of data you give. We can make it highly powerful, or we can show higher values from the data. And then he said, if I give you LinkedIn data and only my profile data, can you do something? Can your innovation engine work on that? I told, yeah, you give us, let's see. And that's when he shared his data. And his data has he shared with us two data sets. One is user connection and the other one is user contact. Can you go to the next slide? We'll just show the structure of the data set. Yeah, so one is contact and one is connection. So this is the very I can say this is very basic data, and it's is with respect to one person, that is Durga. Okay, can we move back? It was a challenging thing for us because we wanted to show that yeah, innovation can be done on a data which belongs to only one person. Okay, but then as we started taking it through our framework and the way we look at the data, the way we approach a data problem, we came out with a nice interesting use case. We thought that can we not build a journey analytics for Durga? So Durga has been leveraging LinkedIn platform a lot to build his professional network, to build his business, to take his business to the next level. Let's build some kind of journey analytics so that Durga knows how his journey has been on LinkedIn platform. Okay, in what way he has leveraged LinkedIn as a platform to grow his network, to grow his business. And also Durga may not know few things which is happening underneath the data. As I told, the data is always huge. There are few things which are happening which you may not know, which you may not like to happen with you. Okay, but unknowingly you may accept some request you without knowing whether that request came from a genuine guy, or it has come from a malicious domain. A person with bad intention is trying to reach out to you. All those things may be happening in LinkedIn for platform. You don't, a lot of times we don't care, we just click the accept. Okay, so that's where we thought, let's build a platform which will help Durga to understand his entire journey with respect to LinkedIn, and to understand his activity level. If any life events have happened in Durga's, when I say life event, these are professional life events. If Durga started a company, what was the response of LinkedIn when he started his company? Do we see a surge? Do we see a fall when he started changing company, or when he started posting some interesting materials on LinkedIn? So basically, how much LinkedIn is helping him to grow as a professional. So all those things. And dynamism in association, like what kind of people are getting associated with Durga. Is it all those associations are really helping Durga, or are there some associations which Durga need, but that is not what is happening on the platform? So without proper analytics, you never get to know who are the guys who are getting connected with you. Your aspiration would be to get connected with, let's say, data science leaders. If you are in a journey where you have learned data science, you are applying data science, now you want to get connected with some of the data science leaders, thought leaders, to understand how they take data science to their organization and leverage it, so that you learn from them. And you want to consciously build network with those guys, but in reality it may not be the case. You again, still you are getting added to, let's say, data engineers or software engineers. So your career aspiration is something, but things happening on the ground are different. So that is what dynamism and associations will talk about. So that's what we have built, which we will demo you. And again, tech stack was consisted of Python, MySQL, and Tableau. And the analytics journey, as I mentioned here, it started with data study. When Durga handed over the data, we went into the data, understood what are the various data elements. Also, we tried to uncover some of the quality aspects of the data to understand whether data can actually go to the next level where we can use in innovation or data science or analytics. All those things we did. Then after post that, we started that innovation exercise, putting Durga as the entity, and around Durga we were trying to build Durga 360, you can say. And then we started building descriptive analytics on his 360, and then deep mining and modeling activities we did to come out with what we are going to demo you guys. Okay, from innovation, yeah, I think all these things I covered. Yeah, let's go to the. Okay, so I think I will hand it over to Sabitra, because he was the guy who developed it, and he can take us through the tool.
Sure. Thanks, Arya. Hi, everyone. So, what do we have here? In front of us, we have something that is very different from what a simple exploratory data analysis could have got us, right? So, when I'm given such a simple data set, I'm not only me, most of us are just tempted to build some exploration on that and do some basic, let's say, postmortem analysis or descriptive analysis, maybe statistical, maybe some graphs. But how do we deep dive and get the innovation in from then, right? So that's what we're going to show you right in front of us. So if you just look at Durga as an entity, what do we see from his LinkedIn behavior, right? So we see that he has about 24,000 connections that was built over 160 odd months, right? So let's say we have more than 10, 15 years, or let's say close to like 12 to 14 years of data for Durga. And in this period, he has somehow got connected to about 24,000 people. And you would be wondering, okay, some of them may directly reach out to him, some might reach out through email, some might have just got connected through on a mobile link of LinkedIn, and so on. So these are the sources that we're talking about. Now, what first should like excite me is, are the people who are coming to me, do they kind of belong to one particular cluster of IT firms, or are they more or less dispersed across multiple geographies, multiple companies, multiple titles? And by titles I mean, are they a software engineer, are they data scientist, are they machine learning engineer, are they data engineer, and whatnot, right? So that is the first lens on which we kind of split. So if you look at the geospatial analytics piece, you see that his connections are kind of globally spread. So he has some connection from the US, some across Asia, and so on, right? And next to the geospatial analytics, what do you see? You see a moving chart which is kind of dynamic in nature. It tells me that from 2006 till like 2019, and that's the point where till which we have the data, we see how Durga's connection has been growing, right? So not only does it give me a yearly estimate, it also gives me a cumulative estimate. Now, what does that tell me? It shows me that somewhere in 2017 there's an abnormally high spike, right? So now that gets me thinking, why, what could have led to that spike? Did Durga like set up his firm at that point, or did he do something on LinkedIn that attracted many people, right? And then we brought this to his attention, and then that's where he mentioned that he had written, as Durga kind of writes a lot of blogs. It was one such blog about him and his journey, and which was uh, pretty much inspirational for many people like us in the industry. So that was an amazing blog that kind of not only garnered a lot of eyeballs, it also led many people to join him as a connection, right? So that led to that abnormal spike. Now, just doing an exploratory data analysis might not really give you all of these flavors together, right? And when I speak about multiple other flavors, we need to look at the bottom part of this panel, where we see, okay, Durga has maximum connection from Tata Consultancy Services, followed by Cognizant, Infosys, Accenture, and so on, right? And we similarly get a title distribution of such people. But what we may or may not really get from this base data is there a risk to just keep on adding someone, right? So that question kind of gets answered by the last block that you see that talks about email domain distribution, right? So what we did is we went ahead and tried to mine the domain from all the requests that Durga gets. So as long as you see something coming from Gmail, Yahoo, Hotmail account, you are more or less relaxed, saying, okay, what if I scroll down, I see that there are certain emails which don't really inspire a lot of confidence. If you see the last one, it's not oracle.com, it is oracle3.com. So does it sound something that is not what I expect? So my trust level from someone at oracle3.com would not be the same as someone from a genuine domain, right? What if someone is trying to enter into Durga's network? What if someone who has ab.com, 3lk.com, oracle3.com has an malified intention of kind of infringing into Durga's network? So Durga would never know this if this level of insights is not presented to him, right? So now we're talking about Durga as an entity. Think about this as an organization, right? So if you extrapolate, think about that we have the C-suite people in an organization, the chief marketing officer, chief executive officer, chief data officer, and so on. So a lot of people would be willing to get connected to these people, right? So not all the requests that these people would be getting, the C-suite people, would be really genuine people, right? They could be pranksters or malicious intent, people with malicious intent, right? Trying to get into the network. So when we do an analysis, when a similar analysis of all the C-suite people, are we able to figure out a cluster or a trend that these are the set of email IDs that are very common to, let's say, 7 out of 10 people? Why do we see this worrying trend? Is there a trigger that we can generate to inform these people not to accept such requests, or maybe exercise caution before accepting such requests, right? So as they say, prevention is better than cure. Why not have something that tells them that be aware, right? So this is a very powerful message that we can project by just analyzing these simple things, right? Yeah, I think you can move to the next one. Right. So now let us deep dive into the meat of the matter. Right. So again, Durga as an entity, let's move from left to right. What we see is his name, his rate of growth in the last uh, 6 months. So we see that, okay, after a period of times, for some reason, the number of connections started plateauing out or maybe decreasing. Right. When was the first connection that he had? We have the date. When was the oldest connection and the latest connection? We have those dates. So again, we are making a 6-month comparison. So maybe for some reason there were a lot of influx in the earlier 6 months compared to this. But what about journey? So when someone asks how has his journey been on LinkedIn, I'm pretty sure none of us can answer by just having that restricted view of the data in the Excel, right? For that, we have to build an innovative story around that data. And how would we do that? That's where we have leveraged our innovation engine. We have come up with a mathematical framework to calculate the journey index of like whatever connections that we have for Durga, right? So again, this is a completely maths and statistics driven approach on the simple data that we had, right? So we calculate the journey index of people, and what we have done is we've split his entire 13-14 years of journey into 3 phases: phase 1, phase 2, and phase 3. So as is expected, when someone starts off, the rate at which people get added will be lower compared to a second phase or a third phase. That's very obvious from the journey index. So if you look, his first phase journey index was somewhere close to 17, that rose 200 odd, and now it's 400 odd. Which, if you see his journey on the connection growth graph, right, you see that like less number of people were getting added earlier, but suddenly there was a spike, and that spike was, again, as I mentioned, we mentioned the reason for the spike. That has kind of led to a higher journey index, right? But is journey index a sufficient indicator for all the answers that we might seek? Probably not. So how do we further enhance this? So combining journey index that we have derived with maybe something as segmentation. Segmentation is a very powerful concept in machine learning. How do we segment the journey index that we have got for everyone into something called trending, something called stable, dying, or dead? So what that could mean is, what are the titles? Let's say by titles, again, we have machine learning engineer, data scientist, founders, directors, whatever. What are the titles that are trending? Which means they're on an upswing. So the curve or the slope that I should see for them should be an upward slope, right? So if just like Mahi has clicked on trending and he has clicked on software engineer. Software engineer shows me that if you look at the time series graph, right, it shows me there is a consistent upward movement, right? And if you see, there is a dotted line which tells me about the slope of the graph. Now, which means that in Durga's portfolio of connections, he has consistently getting more and more requests from software engineers from the time he started till about the recent past. So this tells me that maybe software engineers really like Durga more than maybe other designations, right? But if he's thinking who are the titles who have somehow stabilized over time, which means neither there is an upswing, neither there is a downward activity. So that's where he goes for stable, right? So he sees, okay, so many stable titles are there, but let's see data engineers, which means that For a long time, the number of data engineers are more or less constant when it comes to getting added to Durga, right? But what should concern him is, are there some titles that are dying? So when I'm saying dying, it doesn't mean a natural death. It means, is the trend on a downward curve, right? So as you see, for founders, earlier more founders were getting added to Durga, but as time has gone on, like maybe the number has reduced, right? So with this, uh, just extrapolate this to an organization, right? So with a single person, you're able to get this powerful message across. Imagine if I'm doing it for 1,000 people in an organization. I'm doing it for this executive team, I'm doing it for the leadership team, I'm doing it for their chief executive officer, chief marketing officer, and so on. So now imagine if I see that I desire to get added to more people from XYZ category, but is my desire and the reality in sync with each other, right? I might be under the impression from the data that I have, which is about a 4 or 5 column data that we just saw, it's nearly impossible for me to determine whether my desire of getting connected to maybe a data scientist or a data engineer and what the reality is, are they in sync? Yes or no? I can never answer that question until I run it through the innovation engine that we are just trying to show you, right?
And then sorry
Yeah,
to interrupt, Savitra. So
sure.
when we showed it to Durga, and Durga did not know most of the things which we showed him to. And then we were thinking it can be a product in itself, where all of you guys have LinkedIn account, but do you have a view like this of your account? I don't think anybody would have a view of this. So we were thinking, if we can build a product which anybody can access, just upload their LinkedIn profile data, and then they get to see what is really happening. Accordingly, they can decide how they want to revamp their LinkedIn profile, or how they want to get connected with their with the kind of people they want to get connected with. So all those strategies they can build once they see the analytics happening like this.
Yeah, actually, to get to that, I'm working on the requirements for this, not only from LinkedIn, but also Gmail provides APIs to get the email data. I want to integrate that email data with LinkedIn data and build a product around it, which will actually help us in the lead generation aspect of most of the startups. So I will announce once the requirements are ready. I'm currently in US. Once I'm back to India, I will try to work on that. I have a team, and definitely I will take the help of ByteIQ in that process, or we might even partner together to deliver that.
Thank you, Durga.
And LinkedIn have played a pivotal role in my growth. I came from a very nominal background, and I don't have very good references throughout my career. One of my mentor or lead in 2004 suggested me about LinkedIn, and from then I started spending good amount of time in LinkedIn. And even though there are some serious issues when it comes to running the company since I started, due to LinkedIn only I am surviving today. And
Yeah.
even the leads from my first company are giving references, and I'm getting some projects. So LinkedIn is have played a pivotal role, and I thank LinkedIn for that. And with respect to this these things, this is very basic view. And if you are, after looking this trending, stable, dying, etc., right? Can you click on stable, Mahi? If you look at this, there is a data engineer, there is a big data engineer, there is big data. All these things can be clubbed together. So there is a
Yes.
concept of fuzzy matching, and we can actually improvise on the data a bit after going through the initial patterns, and then using the concepts of fuzzy matching, we can club these related roles together, and we can make it a lot more realistic. But just for this demo, we haven't gone to that route. But we can improvise on this by leveraging some of the key machine learning concepts or even regular analytics concepts. Yeah, go ahead.
Yeah, thanks, Durga. Thanks, Arya. So now, what do we see at the bottom? What we see is something that's very powerful in the world of data science. That's called word cloud. So the power of word cloud is unparalleled when we come to natural language processing, or let's say text analytics for layman, right? So how have we leveraged that? So word cloud, as you see, gives you a very appealing and alluring pictorial view of how data has been stacked. For example, if you see in the first phase of Durga's journey, we saw that, okay, mostly the consultants, directors, project manager, software engineer, etc., got added to him. But as he moved to the next phase, technical recruiters started emerging as key entities of people who are getting added. So maybe Durga at during the second phase could be more willing to partner with technical recruiters, right? And as we further move on, we see that just at the beginning of the third phase, the world of data science exploded, where everyone was talking about data as the new oil. Everybody aspired to be a data scientist. So being a data scientist was the go-to goal for most people in the world of analytics. So towards the beginning of his third phase, the number of data scientists in this market exponentially started growing, and it's been still growing, as you see, right? So that is the reason you start seeing data engineers, big data engineers, data scientists, etc., in the third phase, right? So what happened is, this actually ties out to what the trend that we actually see in the market, right? So this in a way gives us a picture of, okay, how have we jumped across designations during my three phases, right? So I think that's all we had for this. Maybe we can take since we can take up more questions as we come along. But yeah, over to you, Arya.
Okay. Any question before we move to the ML model development? Fine. Then let's move to. Okay. So here we are going to demo one machine learning model development using logistic regression, and it's in the world of banking. I hope all of you, or if okay, let me explain bank in very simple words. Bank is in the business of offering credit, deposit, and investment products. These are the basic three products which you typically see when it comes to a bank. Either they are giving credit to someone, or they are taking deposit from people who have extra money in with them, or it is selling some investment product where it is making where it is collecting some fee. So for example, it could be a mutual fund which it is selling on behalf of an investment management company, and it is making some fee. So these are the three major product lines which you see in bank. And within credit, we have again sub lines, like you have credit card as one business line, you have mortgage as one business line, you may have auto finance as one business line. Okay, in deposits also you may have you will see savings as one business line, fixed deposit as a different kind of business line. So all these are the products which a bank in today's world offer to its customer. Now, this particular business problem which we are going to target is about term deposit. So term deposit is basically a fixed deposit product any financial institution offers to customers, and it will have varying maturities ranging from a few months to few years. Okay, and this deposit is highly critical, because in order to lend money to needy people, bank needs enough deposit. Okay, and the difference between the loan rate and the deposit rate is what bank makes as revenue. Okay, and obviously their expectation would be to collect low cost deposit and offer a loan at a higher rate. Obviously they are the loan maximum rate is capped by the regulators. It could be Fed Reserve in US or RBI in India. That's capped. But yeah, the objective is to make as much as possible from the loan. Now, every bank would like to get more term deposit into their organization, and they try to get it through either cross sell or upsell initiatives. Okay, and how they do it through campaign management process. Every bank has a campaign management process where they reach out to potential customers for the products which they have, and the potential customer can be an internal customer or it can be an external customer. And when I say campaign management, the end product of a campaign management process is someone calling up the customer via phone, or dropping an email, or sending a direct mail to the customer address to seek his opinion on a product, or to solicit some product and get the customer subscribed for the product. So campaign management has high cost because it involves a lot of data preparation, data analysis, and then people calling up the person via phone or sending an email. So all those are cost. So typically what happens is, when a bank is rolling out a campaign, they see that out of 100 people they reached out to, 3 or 4 people actually showed interest in that. So the hit rate is very low. People showing interest or coming for subscription of a product is very low. Now what banks were traditionally doing was, they were just following the same approach. They were trying to fine tune their approach here and there, but they were not using machine learning models to come up with a strategy around campaign management. But with the growth of data science, with the growth of data and all those things, the way they were managing the data, it came to a situation where they realized that now, with so much of data with us, we can identify the characteristics of people who generally subscribe to our products. Whenever we launch a campaign, we reach out to 100 people. If 5 people are coming back to us, let's try to understand the characteristics of 5 people, because we, at the end, we have limited budget. We cannot go to 1,000 people. Always we'll have a limit on budget, and that budget may prohibit us from going beyond 100. So in that case, our end universe is going to be 100. But from the characteristics which we see from the customers who are enrolling for our products, can we design the strategy better? Give me a second. Sorry, there's some disturbance. Yeah. So yeah, so they have limited budget. They cannot go beyond 100 people. So in that case, the objective is, how do I understand the characteristics of people who show interest in my campaigns? And that is possible because now I have data of people who have shown interest in the past. If I can derive those characteristics, then I can design my campaign better. I can only while creating those list of 100 people, I can only take those people into that list who are displaying the characteristics of people who have come forward in the past for my product during a campaign. And how to do it, this is where machine learning model will come into picture. So machine learning model will take all the data of the past, will try to learn from the data to uncover what are those common characteristics of people who typically sign up for a product. I'm just throwing a random example. Let's say I'm offering a credit card, and from the past, in last 5 campaigns which I did, in every campaign 5 people showed interest out of 100. And when I look at those 5 people, I see that mostly people having postgraduate degree, people having a salary of more than, let's say, $100,000. Okay, or people who are in the age bracket of 25 to 30. These are the guys who came back to me during my campaign. So these are the characteristics which I know I can apply on my next set of customers when I'm choosing for my campaign management process. Okay, but in real world, data is huge. You have so many customers a bank would have reached out to. And it could be in 100,000 or 200,000, and maybe you have 10,000, 15,000 customers who are potential customers who would have come back to you. So that's where the challenge comes to the picture. How do I look at all this data and derive the insights or derive the characteristics of customers who came back to me? So that's where machine learning model will come into picture. So this In this example, which Mahi is going to walk us through, we are going to see the end-to-end implementation of that machine learning model. Can we go to the next slide? Okay, so this is the overall data landscape when we are creating a data for our model preparation. So basically, model will have training and test phase, which Mahesh is going to talk about. But when we are creating the data for the training and test purpose, the data needs to be very comprehensive. It needs to come from multiple silos within the organization. So in this particular case, we have the data which we are going to feed into model coming from customer master. So customer master is one data silo where we have demographic information of the customer, like age of the customer, the profession of the customer, what's the marital status of the customer, what's the educational background of the customer. So this is all about customers demographic information. Second silo is campaign management. So it's about the past campaigns which the bank has executed. So various parameters with respect to past campaigns, like when the customer was last contacted, okay, which campaign he was, how many campaigns he was part of, what was the outcome of the previous campaign. All those information comes from campaign management. Third is another silo, which is credit risk data mart, which will give us the credit risk profile of the customer, any default in the past, any existing loan, okay, all those things. What kind of loan the customer has, he has a mortgage loan, or one already a card loan is there, any personal loan there. So that's the credit risk profile of the customer. And the last is macroeconomic indicators. This is like the external data, but it's highly critical when we are designing any campaign, because if the, let's say, the unemployment rate is low, then that's not unemployment rate is very extremely high, abnormally high, then maybe this is not the right time to offer credit card to a lot of customers. Or if we see that the let's say the oil sector has crashed a lot, so a lot of unemployment in the oil space. This is, I'm talking from my experience in one of my previous banks. We were building models, and at that point of time there was a huge crash in the oil price. And some of the regions which are highly dependent, which are oil economies, basically in the US, a lot of people had lost job. So in the campaign management process, we were trying to include those as parameters, so that we are not taking huge risk by reaching out to those people who are working in oil sector, who have either lost job or would lose job in near future. So macroeconomic indicators play a significant role. So all the four different data silos, and in real world, all these data will be residing in different data world. Okay, so while creating a data set for the model preparation, the first step is to do a proper brainstorming session to understand what all data dimensions are critical for me to create this machine learning model. We don't, instead of just jumping into the problem solving, we need to spend a lot of time in uncovering what all data sets can come into can come and help me in this model development. Okay, so that's where you get to know about all the possible dimensions, and then you have to design your data pipes, so that data is coming from all those places into your final data set. And then the final data set is prepared, and then that final data set will come into the model development. So that is what Mahi is going to show us in the next phase. Yeah, but this is all about the use case which Mahi is going to show us.
Okay, so thank you,
Any
Arya. So
any
yeah,
question
go on.
before Mahi starts it?
So any question around the use case, like what's our objective, did you get it, or any confusion is there? Okay, fine. So I think before I start, I just want to take one step back. See, now the kind of use case we are targeting now, it's comes in an algorithm of logistic regression. So that, because that's being a classification problem, so we want to show you with logistic regression. That's one of the machine learning algorithm. But the general flow, how we take in a class, is that initially we teach about the theory part or the concept around each of this algorithm. After that, we try to implement a use case around it. That's a general approach we take it. So the kind of material or the flavor I just want to give you, how does it look? Okay, so you'll understand. Yeah, I think you can see it. So generally we go with basics. We start at basic level, at the ground level, and slowly we take it to the next level. Okay, that's why we go with the first basic model so that you intuitively understand what a model is all about. And after that, we try to increase the complexity of the data so that how to implement. Okay, that's like we go in a story way. Okay, before going to math of any model, we just show you how to implement in Python. So implementing any machine learning algorithm in Python is very, very easy. I can say it's just 4 lines of code or 5 lines of a code, any machine learning model. Okay, but you need to know the underneath what is happening. So we just not only teach how to implement, we teach also the math around it. So if any basics are required regarding that particular algorithm, that also we put it in the process. So everything in a story way it goes on. So if you see there's a matrix requirement is there underneath of some algorithm, then we put those basics, what are required. Okay, if you see this is this is related to linear regression, the flow. Okay, so these things we will be covering in the class. Just I want to show you a flavor, how does it looks. So it's not only just that we show it in the Python, we also show the internal things, what is happening under the algorithm, the math around the algorithms also. Okay, so there are different things are there. Okay, and it's as I said, if you see this, so if required, we go, let me show you. Yeah, so if calculus is required under the process, we give a flavor of that. Okay, so we make sure that you get every concept. Okay, we'll go at very basic level and slowly we try to inject more to you. That's what we do it. So once we finish the concept, for everything we have an implementation around it. Python implementation is there. So one implementation will be by using packages that are available in Python. At the same time, we go and implement our own package also. Means the whole algorithm also we implement in Python. That kind of piece of practice also we do it in the class. Okay, so now let me go back to the use case, what Arya has been talking about. Yeah, so this is, as I said, this is we are using logistic algorithm now, logistic regression algorithm to solve this problem. So first of all, when you start it, we generally first we study around our objective. After that, we need to import all the required packages. The most commonly used 5 different packages in Python for data science are pandas, numpy, matplotlib, cburn, okay, and sklar. These are the five important packages that are required for data scientists. 80 to 90% of your tasks can be done with these 5 packages. Mostly 80 to 90% complete a project can be done with these packages. Only these 5 packages are required. Okay, so now if you see, I was importing my data. I'll be running this also. So if you see, I'm importing my data. After that, I'm dropping few of the columns. Okay, so I think it's taking time to import. Yeah, let the data come up. I'll talk about a bit around the data. So our target variable, if you see, it is our whether a particular client is going to take term deposit or not. We are trying to see the potential customer whom to target so that there is a high success rate that he's going to take our term deposit. So if you see our data, this is a sample to see your data. Head is a function, you use it. Okay. So this is data is in pandas data frame, they call it. And this is our sample data. These are top 5 records of my data. And this is my output. This is my historical data where I can see who are the people who has taken the term deposit and who has not taken. Okay. So now before actually any machine learning model works on numbers, that's the reason what are the categorical columns are there. You need to convert them into numerical numbers. So our output, if you see, we have no and S. It's a text. We have a character. So that's the reason we are converting S to 1 and no to 0. That's the first step I'm doing it. Okay. And at the same time, we have one of the column called education. So based on their education also, people may take, some may take the term deposit, some may not take. That's the reason we are just studying around the education column also. In our data, we have different categories of education. That is university degree, high school, basic 9Y, basic 4Y, professional course. There are different categories with the customers. So these are the list and the count of each of this category. Okay. So what we are doing, so generally what we do, like, so based on the domain knowledge, Any question? Okay. Yeah. Okay, fine. Is any question is there for someone? Okay. So based on our domain knowledge, sometimes what they do, they try to combine different categories. So here I'm trying to combine basic 9y, basic 9.4, basic 6y to as basic. I'm replacing those values. Okay. And after replacing the values, if you see the count, this is how now the count is changed. The value count will give the frequency of the each categories. Okay. So in machine learning lifecycle, what is the things you do, right? First step is that you need to understand your objective. And the second thing is that you need to know the what kind of data you need to use for that objective. Once you know that, you try to understand your data. So during the process of your understanding your data, you do different steps. Okay. The ones like you print different kind of things and you do a EDA around it. And I say EDA, it's nothing but exploratory data analysis. Okay. So in the EDA, you'll try to understand your data better, and you ask your business the right questions. Once you go and grill your data and you spend more time on your data, you will ask the right questions to the business, and if you based on that, you will take certain calls on that. Okay. Now if you see your target variable, okay, this is my target variable where I need to predict whether the first customer is taking term deposit or not. If you see our data, the zeros, the number of customers who are not taking the loan term deposit is around 36,000, and the persons who are taking the loan term deposit is around 4,640. Okay. So in our historical data, there's a success rate of taking the term deposit very, very less. So that means they're spending a lot of time on the people who are not taking the loan. Okay. That's the reason if they have a model, instead of that manual process of checking the document or understanding about the customer, instead of that, if they have a model, they can reduce they can reduce their efforts. They can save a lot of money or a lot of time because they need not go that tedious process of selecting a candidate. Now the model is there. Model will tell us what is the probability of that customer is taking a term deposit. Okay, that way the model is helping the current process to improve. Okay, in machine learning world, if you see these kind of is, let's say, if success people who are taking term deposit is very low compared to who are not taking. So there is a unbalance in the category. So one category is high, another category is low. So these kind of data they call as unbalanced data. Okay, if you see zeros are like around 36 and there's 4,000. So when you're building a model, if you are doing in the way it was there, there's a chance of going bias. Okay, whenever your model is finished building, okay, if you give a new record is coming to the model generally becomes biased because you have more classes around the class 0 rather than class 1. That's the reason there are techniques to handle when you have unbiased data or unbalanced data. Sorry, when you have unbalanced data, there are techniques to handle them. Once you handle them, you need to build your model. So during our classes, we will be discussing those also, because those are the common scenarios that we see in the industry. Okay. So if you take a scenario of default also, that percentage of people who get defaults in a particular bank is very low compared to non-default. Okay. So every time that the positive, whatever the negative side of that is there, always would be a low percentage compared to the other side. So when you have these kind of scenarios, there are different techniques which you need to know. That's a common it's a common problem in classification world. Okay, those kind of techniques we'll be teaching in the class. So if you see, as I said, we need to spend more time on the data. If you see, like I was just doing a group by with respect to my target variable and taking a mean. That means I'm trying to understand each of this variable, how they're behaving with respect to each of this class. With class 0, what is the average age I'm getting? With class 1, what is the average age I'm getting? So with these two things, I can conclude that, or take a observation around that, is that people who are having age more are taking term deposit compared to the age less. The age is a factor. I can see that people who are having more age are taking the loans compared to the other. Okay. Similarly, if you say T days is something on previous how many days before you have targeted that customer in any other campaigns. So surprisingly, that people who are recently have targeted, they're turning out to be a successful customers. Okay. Similarly, yeah, the campaign ratio also. Okay. So this in the class also we talk about business angle, how it is helping or how to understand the data. At the same time in the notebook, you see a proper comments around these observations also. So during each of this algorithm, we will be giving an assignment around it. And the expectation is that you also need to do that. So in the process, you will be learning in a real-time way. What is a real old is expecting from the candidates who are coming for data science job. That's what the way will be there. Okay. So similarly, we are studying with respect to job. How does each of under job there are different categories. Admin is one category, blue collar is a one category, entrepreneur is a one category, housemaid is a one category. So these are the different categories we have. And with these different categories, what is the average age around that? See, these kind of things we do to have a better understanding around data. So based on this study, we take a call, and or if you have any questions around the data, we always go back to the business to understand better. Because sometimes data entry could be an issue. That's the reason we may see these kind of values. So for everything, we need to have an answer, proper answer, logical answer. Okay, that's the reason we go back to business with certain questions and get corrected by them. Similarly, I was studying around marital, whether diverse, married, single, unknown. So what is the average age you can see? So diverse people with, we see that more age, 44. That means there's if you target, because age is a factor we have seen, people who are having more age are more chances of taking term deposit. Along with that, a person is diverse, there's a chance that he is going to take a term deposit. Okay, so these are the some of the conclusions I make from the data analysis. This is a data analysis, we do it. Okay, this is one thing. Yeah. So similarly, we do some analysis around categorical variables. So whatever the study we did around the numerical variables in our data. So in our general, any data what you have, there are two kinds of data. One is numerical data, another is categorical data. When I say categorical, it's nothing but a character data. Okay, string kind of characters. Job, if you take a job as one of the column, inside the job I have single, marital, what is that? Okay. So similarly, you have numerical also. When I say numerical, it could be integer, it could be a float also. Okay. So if you see this one more EDA we are doing here. So with respect to job, so what is my success rate of taking term deposit or not? 0 is for blue and 1 is this. Okay. So if you see each of this category have different, the admin, they have more people are taking term deposit compared to any other categories. So each of this category have different frequencies. So that's the reason this job as a one of the column will have some impact on our target variable. So each category in the job have different frequencies. The frequency of purchase or deposits depend on a great deal on the job title. Thus the job title as a column can be a good predictor to our outcome variable. That means this variable, the job variable, will be having a good impact on my person is going to take a loan or not, taking a term deposit or not. Okay, so from the study of EDA itself, you may get the complete picture around which of the variables are going to impact my output variable. Okay, so like this, we check for different different other categorical columns that I have. Okay, let me take one more here. If you see, okay, this is the day you call for the customer, whether it's a Friday or Monday, Thursday, or Tuesday or Wednesday. If you see that there is no difference in frequency, whatever the day you call it, okay, there is little bit of frequency difference. Each of the category in each of the category of day, you see the frequency of taking term deposit is almost equal, but not taking is some difference in frequency is there. So this could be or could not be a good good predictor for our outcome, because almost the frequency is same for the people for the customer who are taking term deposit. Okay, so like this, we do different EDA study to understand our data. So in the process of or in the life cycle of machine learning, okay, so 70% of your time is spent around data importing data. After that, doing a study around the data cleaning, they call it, or data pre-processing, or EDA, or data filling. If there's any missing values, how do you impute it, or data scaling, or feature engineering, you do it. Okay, and after that, once you do all this process, then you go for modeling. Okay, so before going modeling, let me go there. So as I said, as machine learning models only understand about numbers, you need to know how to convert the, if any categorical variables are there, how do we convert them into numerical columns? Okay, there are different ways to do that. Okay, that we will be studying. One is that one hot encoding, they say, or pandas dummies is a one way of doing it. So you'll understand what are the different ways of doing it. Here, if you see, I'm doing, these are the categorical columns that are present in my data. I'm converting them into numerical variables, as a numerical values in that by using pandas get dummies. Okay. And the one thing I can say that coding any machine data science complete life cycle in Python is not that tough. It's very, very easy. Only thing you need to know what is the right methodology I need to use for that particular scenario. Okay, if I give a small example, let's assume that you have a salary column in your data. Okay, out of that, let's assume for 10 salary column I have for 100 employees. Let us assume that out of that 100 people, for 10 of the people, we have a missing values. So you need to know whether I should impute with a mean or a median is a good practice or a mode is a good practice. So you need to know that kind of techniques. What is the right approach I need to take it to fill my data back? Okay, the right choice you need to know. The coding wise, it's not that tough, or you can find in the internet also. So the methodologies to use it, you need to know more. Okay, so after that, once you have a proper data, because now after converting all the categorical columns into numerical columns, so I have been ended with 62 columns, because previously I used to have very few columns. If you see at the beginning, I have around, let me check, 21 columns I have in my raw data. But because of converting all the categorical columns into numerical data, okay, that's the reason we ended up around with 62 columns. Okay, because as I said, machine learning models will understand only numbers, so we need to convert them into numeric. After that, once we have 62 columns, before giving it to the model, if you want, you can do feature selection. Instead of building a model with 62 variables, it's better to select few of them, so that your computation will be faster and it's easy to interpret also. So there are different techniques for feature selection also. So we try to get a study around features which are going to impact my output more compared to out of all the 62 variables, which of them are the top 20 or 15 or 10 variables which have more impact on output variable. So we are going to build with model only with those top 10 variables or top 20 variables. Now here, if you see, I'm taking the variables which are top 18 variables I'm taking, which are going to impact my model more. Okay, so here we are using RFE, okay, recursive feature selection. Okay, recursive feature elimination is a process we use, and we try to get the top 18 from 62 top 18 variables that are impacting my output variable more. Okay, there are different techniques for that also. That is called feature selection techniques. You see, once you have those 18 variables, now before doing modeling, you need to split your data into two parts: X train and X train and X test. That's what okay, here I'm doing. Okay, so generally linear, some of the models are there which are got picked from different areas. If you say about linear regression and logistic regression, they came from the area of statistics old. If you talk about, someone is talking about deep learning, it was built based on neural concept from a biological field. So machine learning is a field. Okay, it's acquired different concept from different areas. Bayesian is something is a different area, and that also they acquired or they put it in a ML world. So when anyone talks about linear regression or logistic regression, they have two approaches to solve it. One is statistical way and a machine learning way. So business in the industry, it is expected to know both. So during our classes also, we'll be teaching that. See, whatever the industry is expecting from the candidates who comes out, we will be teaching in that way. Okay, so you see, for logistic regression also, as I said, implementing a model with Python package is not that tough. If you see, I'm importing a package that is OLS to implement my model, and I'm just passing my X, my Y, and my X. That's it. These are the 4 lines to implement a model. Okay, this is statistical way of doing. There's a machine learning way of doing. That's where first you would split your data into train and test. Okay. So if you see I'm splitting my data into test size is 30%, that means 70% goes into train and 30% goes into test. Okay. So we split like there are functions for splitting the data also. You just need to mention the test size. After that, if you see to build a model, you first need to import your logistic regression from the right package. After that, you initialize it with a reference variable. That reference variable dot fit is the model implementation. See, hardly for the complete data, whatever we've seen until now, hardly 3 to 4 lines of code. So the implementation side is very easy, but the things you need to know is the math, what is happening around it. Okay, those are expected during your interview process. So that's where we try to focus more around that. Okay, so once you have the model, you need to test on your test data. What is the accuracy I'm getting? If you see, my model accuracy is 90%. That means 90% is a probability that my model will be having the success rate. So tomorrow, if I'm getting a new data of customers, what I'll do, I'll pass my data to the model. Okay, and I'll get my output. Based on that output, I'll take a decision. If you just remember in our previous time when you want a loan, 10 years back or so, when you want a loan, we used to submit a document. So they used to take the documents and they used to take 1 week or 2 weeks of time to check it under the underwrite conditions. Okay, this person have met these conditions or not. After that 1 week, they used to say whether, okay, we can give from you a loan or not. But in today's world, if you see, they used to have an app. In the app, they enter all the details of us. Okay, is married or not married? What is his current salary? Okay, which company he is, which the company belongs to which category? Okay, whether he has any other loans or not. So they enter different parameters, 5 to 6 parameters, and they submit it. Immediately they're getting a result because at the backend, model will get hit. When you submit the data, data goes to the model and model will return a result of it, whether person we can give a loan or not. If we can give the loan, they can also predict what is the percentage of amount we can give a loan for him. So there are machine learning models. So now the decision is taken in real time rather than waiting for a week or 2 weeks. After that, they're saying, okay, we can give a loan or not. So similarly here also in the term deposit, you can create that kind of thing and get results in a real time. So a lot of time is saved in the process because they may spend a lot of money to go to the complete process. So that is got reduced with ML. Okay. So once you get accuracy on your test data, they generally check the confusion metrics. So confusion metrics tells us how many true positive and how many true negative. So these confusion metrics or classification report, okay, that's what the classification report you see, or precision or recall or F score. These are the different metrics that are used to interpret our model, how accurate our model is that. Okay, these concepts also how to interpret your model at the end of your use case you'll be learning in the classroom. Okay, this use case is just to give a flavor the way how we teach it. Okay, so that's it from my side. Do you have any questions? Yeah, model deployment we will be covering. Okay, we will be covering at the end we will be having just an example of how to create a web app, and after that how to deploy it in a cloud environment like Heroku or so. Yeah, that is covered.
I think in the last introductory call, we showed all the things we are going to cover in the training, and we have sessions dedicated for hyperparameter tuning, cross validation, full cycle of model development, auto ML, and model production readiness. So all those things will be covered.
And also those who will be enrolling for the training, you will get free lab access to IT University where you can practice big data, free content, and also beyond data science, I have covered some of the important topics to improvise your Python skills. Even that will be shared with you. So these are the additional key takeaways for those who are joining this batch. Typically, that itself is like $400 to $600 depending upon the volume I get, but I'm including that as part of this training itself. So you don't need to pay anything extra.
So one point I just want to highlight again. So as you have seen it, implementation in Python is very easy, but our focus is more around what is happening inside that algorithm. Okay, how to tweak it or how you can implement it by your own. So just imagine tomorrow if you got an opportunity to work in C language or C++, where your machine learning algorithms you need to implement. Because in current world, we don't have any ready-made packages that are available in C or C++. You need to implement. So when you can implement? When only you once you know what is happening inside that algorithm, then only you can implement. So we go in that level of explanation, which are required and which are expected during your interview process.
Okay. Okay, Samba, what we will do is that we can forward you the video, or the video is already there in YouTube. We can share the link with you so that you can watch the video and see what all we covered in the introductory call. Mahesh, one more question from Samba.
So somebody, did you join the WhatsApp group? If not, we will share the WhatsApp link.
Yeah, you join the WhatsApp group. There we will share the video.
Yes, sir. Hello?
Oh, there is some background noise. Okay.
Yeah,
So
I just unmute. I just did unmute. Yes, I joined the WhatsApp group. Hello?
okay.
We'll
Yeah,
share the link there. We'll share the link there.
and also, if I want to discuss like personal questions or something like that, boom, I can discuss.
You can talk to Arya about it.
Yeah, yeah.
Or yeah, I think so. I think we have his number in the group, right? WhatsApp group.
Yes, yes,
Yeah,
yes.
he is one of the admins.
Yeah.
I will ping now.
Yeah.
So that
Yeah,
I will
you
mention.
can. I think you can see my name. I will ping. I will save your number and I will ping you. Okay.
Fine.
Thanks.
Let me ping immediately.
So Srini on YouTube. Okay. Srini, I have already added you to the WhatsApp group. The same WhatsApp group
I'm part of it.
about. Yeah.
Part of it. Like I'll get if you have that link, like I just place it there so that I'll get it.
Yeah.
Also, I will.
Sure.
What I will do is that I will share the. Let me share the brochure also, so that you guys can. Let me immediately post there.
So anyone from YouTube, if you guys want to join WhatsApp, you can see the second link from the top. Sorry, first link from the top in the chat, and you should be able to click on it and you should be able to join. Okay. Anything else from anyone? Okay. Thank you very much for joining the session. I hope we will see some positive feedback from you and some interest. At least few people will be willing to join. If yes, feel free to follow up with me or Arya. Due to the COVID situation, the response is not as per our expectations. So if you are really serious, please express your interest so that we can come up with a plan and start the enrollments. Last time the response was a lot better than what we have seen this time. We understand the reasons behind it. That's why we are also a bit curious. If you're really serious about it, please reach out to me and Arya, and then we will actually take it further. And as of now, the dates are a bit tentative. We will decide based upon the response. Yeah, go ahead, Arya.
Yeah, and this is not going to be a short-term program, so it is going to be a long-term program for next 4 to 6 months, you can assume. So I'm pretty sure by the time we complete the program, market would have turned around a lot. So that's an opportunity for you guys to position yourself as a data scientist for the market by the time market is good.
Okay then. Thank you and stay in touch. Bye.
Thank you, everyone.
Thank you all.